Okay, thanks. Okay, so some people can hear banging. Jessica can hear banging from the radiator. Some people can't. So this is Kathy Halverson. I'm going to be running the webinar. We're going to start in a moment. Thank you for joining us if you're an attendee. And I'm going to try to apologize several times for those of you who can hear the banging radiator. There's nothing I can do about it. I turn the heat off. It should go away soon, maybe when the heat does shut down. Okay, we're going to go ahead and start. Welcome to the ACE, IASNR, SCB, SSWG. And I was getting a little bit of echo, so I'm muting the panelists. Mark, can you mute yourself? You're able to? Okay, thank you. We're just getting a little echo, so panelists, if you're not speaking, if you can just mute yourself. So welcome to the Association for Environmental Studies and Sciences, ACE, International Association for Society and Natural Resources, IASNR or IASNR, and Society for Conservation Biology Social Science Working Group, SCB SSWG webinar. We're excited to have all of you participating. I'm going to do a little bit of an intro here. And I'm Kathy Halverson from Michigan Technological University. I'm Executive Director of IASNR or IASNR, and I'm also on the Social Science Working Board of the Society for Conservation Biology. I'm going to be facilitating the webinar today. First, I want to thank Stefan Hersebies and Michigan Tech's IT department for really great webinar support. Thank you very much. I want to let everybody know that this webinar is being recorded. And I want to thank Paige Fisher, who will introduce herself in a moment, Jessica Hill, who is IASNR staff, and our 4 presenters, as well as those of you who are attendees. And attendees, you are going to be muted for the entire webinar, so just keep that in mind. In the Q&A session, you'll be able to ask questions by typing them in, but we're going to open that later on. And again, I'll apologize for those of you who can hear my radiator banging in the background. There's nothing I can do about it, so just hang in there, please. Okay, so I want to acknowledge our sponsors, ACE, and there's their website URL. They publish the Journal of Environmental Studies and Sciences, or JESS, and host the ACE annual conference, as well as the International Association for Society and Natural Resources. There's their website URL. We publish the Journal of Society and Natural Resources, and our conference is the International Symposium on Society and Resource Management, or ISSRM. And the Society for Conservation Biology Social Science Working Group, that's our website URL. We publish conservation biology and some other journals. Every other year we have the International Congress on Conservation Biology, ICCB, and then on the other years we have regional congresses like ECCB and ACCB. So I want to do quick introductions of some of the folks who are presenting, and or can just unmute. Okay. Hey. We're waiting for my mouse to function properly, but IT is on it. Paige, I think you're unmuted, so if you could just go ahead and briefly introduce yourself, please.
Sure. My name's Paige Fisher, and I am the chair of the Professional Development Committee at IASNR, And one of the things that we do is coordinate different services for our membership, including professional development services relating to learning about new methods and scientific knowledge as it relates to society and natural resources. And so this webinar is one of the things that we have helped offer to our membership and beyond.
Thank you, Paige. Aniseh?
Hi, everyone. My name is Aniseh, and I'm actually in transition. I just finished a postdoc at the University of Michigan, and I'll be joining the Department of Sustainable Development at Appalachian State University this fall as an assistant professor. And I'm really happy to be here. I'm looking forward to hearing all of the presentations today.
Thank you. And another one of our presenters, Matthew Hamilton.
Hi, everyone. I'm Matt Hamilton. I'm an assistant professor at the Ohio State University School of Environment and Natural Resources, and delighted to be part of this webinar.
Okay. Peter?
Hi, I'm Peter Hackus. I am a professor of political science at the University of Central Florida, in addition to the National Center for Integrated Coastal Research, and current president of ACE.
Okay. And Mark?
Hello, everyone. I'm Mark Rouleau, assistant professor in the Department of Social.
Oops. Mark, I just accidentally muted you.
Okay.
Sorry.
All right. I'll try again. I don't know how much you
can
caught. Mark Rouleau, assistant professor, social sciences, Michigan Technological University. I've got a political science and computer science background, which will make sense when you see my presentation.
Thanks. We're having a little bit of mouse problems, and so bear with us. Thank you. All right. So I just have a little bit of introduction to go through, and then we'll be ready to move into our presentations. So first of all, thank you again for being here, attendees. And I want to note that your membership in one or more than one of the different associations that are hosting this is really critical. So please make sure to join one or more of the associations hosting this, sponsoring it, and or renew. And for those of you who are members now, thank you for being a member. The goal of the webinar today is to give environmental social scientists, practitioners, and students a taste of less common, newer social science methods options. All of the presentations and resource lists are in the Google Drive that you have access to. They're in 2 separate folders. We're going to spend the first hour having our 4 presenters talk about each of the methods in turn for about 12 minutes each. Then we'll go into the second hour, which is going to be the Q&A. At that point, we're going to open up the Q&A window. We'll take about 10 minutes per presenter, starting with Aniseh first, and you'll be able to type questions into the Q&A window. You'll write a question and the presenter will answer it orally. So as people are presenting, I would recommend that you take notes of your questions during their presentation. The Q&A window, again, will open after presentations are done. I also want to note there is a very short poll with just 2 questions at the end, so please hang on to complete it. One of the things we're going to ask you to answer is which of the methods you'd like us to do a fuller potential workshop on. All right, that's it from my end. I'm going to turn things over to Aniseh.
Well, thank you everyone for joining us today. Today, I'll be giving a very brief overview of some experimental methods that can be used together with surveys to elicit information from respondents that might be a little bit harder to elicit in using commonly used survey questions. This list is by no means exhaustive. There are many other methods that can be used, and some of them you'll be able to access through our the resource list that Kathy has prepared. So one of the reasons why experiments are very helpful is that, is everything okay? Yeah?
Aniseh, we're trying to turn over control of the slides to you. You should be able to take control and advance the slides as you want to.
I am not able to. Let me see. Did I do that? Okay.
Yes, yes, you did.
Okay, good.
Thank you.
So like I was saying, one of the reasons why experiments are helpful is that people often have biases, both implicit and explicit, that might color the type of answers and responses they may give to traditional survey questions. So for example, if I asked you, are you a trustworthy person? What are you going to answer? You're going to say, of course I'm a trustworthy person. You can trust me. I'm a good person. So experiments allow to get information about trustworthiness, for example, without having to ask that question directly to the respondent. So I'm going to be going through 4 different methods. Like I said, this list is not exhaustive, so you can see more of them in the resource list that is provided. The first method is the choice experiment, which is a method that was developed in economics to study how consumers make decisions when buying different goods. So for example, it allows researchers to determine how much a consumer might pay for an organic label in the product that they're buying. Choice experiments have been used in a variety of different contexts as well. So we can learn about how individuals value ecosystem services, or how whether individuals are willing to change their behavior or accept a change in their practices of how they manage natural resource, for example, based on the results from choice experiments. So as an example, this is a choice experiment that I used some years ago to understand and get a better sense of whether farmers would be willing to adopt intercropping in their coffee farms. And by this, I mean whether they'd be willing to incorporate shade into their coffee farms. So I presented a series of hypothetical choice scenarios, like the one that you see in front of you. And each respondent had to answer, had to decide whether they would be willing to switch to an option that is presented in the choice set, or if they would be willing to just continue farming the way they are farming. By repeating this exercise multiple times with different levels of each attribute, so different levels in this case of how much labor requirement it would take to switch to this new farming practice, or what kind of assistance through extension service they would get, I was able to determine the conditions under which farmers would be willing to adopt shade into their farms. Another method is the risk game. Risk games are used in economics and other fields like psychology to get a better understanding of the risk preferences that individuals have. And by risk preferences, I mean whether people are willing to take risks or they're not willing to take risks, or very risk averse. And risk taking is something that can be good when it results in people adopting practices or technologies that will result in improved well-being, or it can be something bad when it means that they're more willing to take risks that could cause personal harm. So as an example of a risk game, I cannot go forward, so if someone can help me.
It says that we're waiting for you to take control of the screen.
Oh.
So you want to try again? Yeah.
Let me see.
There you
go.
That's you. Yeah, you got it.
So this is an example of a game that I conducted where we used a very simple method of putting 6 balls into a bag. 3 of those balls were orange and 3 of those balls were white. And we told farmers, listen, there is a 50% chance that this upcoming harvest will fail. If the harvest fails, you will not be making much money at all. But if the harvest is successful, then you'll be making all of this money. And there's these 6 different scenarios that have different payoffs associated with the choice that you make that will determine whether you get the kind of payoff that you get. So farmers would then choose one of these 6 cases, and after the choice was made, they selected a ball from the bag. And if the ball was orange, then they would get the actual payoff associated with the choice that they made. So for example, if someone is very, who's willing to take risks, they would choose the last case, which has the 0 payoff for the bad harvest and has the 350 Cordobas, which is 3.5 days of labor for a good harvest. Someone who is not willing to take any risks at all will go for the first option, which no matter what the outcome is, will result in equal payoff of 100 each. And this is something that happens when you know what the outcome is. There's a 50% chance of bad harvest and 50% chance of good harvest. When there's ambiguity, you can also change this game a little bit, and you don't tell how many orange balls are in the bag and how many white balls are in the bag, and you see how they, what cases they use. So this is how you deal with ambiguity or uncertainty about the future probability of a bad or a good harvest. Another common method that is gaining a lot of attention is the common pool resource games. And these are games that help researchers and institutions to get a better sense of how individuals and communities manage commonly held resources like fisheries, water, forests. And these games allow to see how people collaborate with each other, how willing they are to take risks and either degrade the resource or protect it. One of the famous examples of this game was conducted by researchers at the University of Los Andes in Colombia and Arizona State University, where they conducted these games in Latin America and Asia, where they brought people together and they said, this is your forest. And if your forest has this many trees, you individually can harvest a maximum of XYZ trees. And then individuals had to make an anonymous decision of how much them as individuals would harvest. And as they see this stock of the common resource lower or improve or increase, they make different decisions. And as a researcher, you're able to see what is sort of the tipping point in which are individuals going to be harvesting all of the trees and degrade it completely, or are they going to work together to protect that resource for their communities and for their households? And this game can be changed and tweaked to accommodate any kind of other resource, and the rules can be made by the participants or the rules can be made by the researcher. So it's a really flexible game that allows for really interesting insights that institutions could use in the future to implement policies for the protection of that natural resource or for the management of that natural resource. Finally, the last game that I'll talk a little bit about is the trust game. The trust games are loosely based on the prisoner's dilemma. And these games help to get a better sense of whether people are willing, are trusting, are willing to give their trust to other people. And also they allow us to determine whether people in general are trustworthy or not. How will they manage the trust that has been given to them? This is a game that was conducted by a colleague where she conducted surveys, household surveys, and she had the husband and the wife work together as a team where one of them, let's say the wife, was selected as a sender of money, and the other person, let's say the husband, was the receiver. And the sender has two choices. One, it can accept $20 from the researcher, or $20 or 20 pesos or 20 whatever from the researcher, and can choose to then just split that $20 evenly between husband and wife. Each person gets $10 and it's all good. Hands washed, the game ends. Or they can say, give me $30 instead to the researcher, and I am going to trust my partner, in this case, my husband, to decide how he will split that money between the two of us. So in an ideal scenario, if the sender is trusting and the receiver is trustworthy, the receiver will split the money evenly and each person will get $15 each. So the final outcome is higher in the second round of the game than in the first round. But the sender is also running the risk of, the receiver deciding, you know what, I'm just going to keep the $30, you get nothing from me. So this is a way to measure A, whether a person is trusting, and B, whether a person is trustworthy. So there's many other games and methods that can be used to elicit other types of information. I hope you do use the resources that Kathy has provided. But just to finish up, some of the things that help with improving the reliability of the results are, one, actually using real payoffs in the game. So if you're doing the trust game, tell them that whatever the split is, you will keep that money. Or if you're doing the risk games, whatever the outcome is from taking the ball from the ball, you will keep the money. And that makes the results a lot more reliable. I mean, even just think about how you may play poker when you're playing with fake chips or with real chips. Do you play differently? And then the other thing that I just wanted to mention really quickly is that although some of these games can be done without, through mail surveys or other kinds of surveys, having these set up in person often help with the creation of a lot more reliable results, because you're able to really explain the game well and check to see that they understand the game. So with that, I'd like to thank you, and I look forward to any questions that you may have.
Thank you, Aniseh. So we're going to switch over to Matt now, and just trying to unmute him. Okay, and then we'll switch over to giving you control of the mouse in a moment. Hey, Matt, you should be able to control the screen now.
And I just do that with, oh, perfect. Okay, terrific. So, so I'm Matt Hamilton at Ohio State University. And all right, so network analysis in environmental social science. So in a nutshell, network analysis is like a set of approaches for testing hypotheses or for otherwise investigating interactions. So let's say, can you all see my mouse down here? Moving it across the screen, hopefully. Okay, so let's say we have a network here. We can use network analysis to describe the structure of that network. And that would be in the realm of descriptive analysis. And I'll get into that in just one second. We can also use network analysis to describe, to do like inferential and network analysis to test hypotheses about why we might observe a particular structure and not one other structure. So for example, how certain factors shape the structure of that network. And there we would be treating the network as essentially the dependent variable. And we can also evaluate the implications of network structure. So here we would be treating the network as an independent variable and trying to understand how different configurations or different characteristics of that network would be shaping outcomes of interest, for example, environmental quality. So, well, what is a network? Well, a network is, in the simplest sense, a set of nodes and linkages among those nodes. So you can operationalize a network in lots and lots of different ways. In the context of environmental social science, nodes could represent, for example, people, organizations, institutions, for example, decision-making processes or community groups, things like that. They could also represent concepts and factors that might exist in someone's mental model or cognitive map or something along those lines, especially because so much environmental social science is dealing with, the kind of entities that exist spatially, habitat patches, places, kind of biophysical entities and things like that. Those can also be represented as nodes. And then linkages might be represented in terms of collaboration between people or organizations, exchange of information, co-occurrence of concepts in some document about environmental legislation or something like that. Or in the realm of these, kind of biophysical entities, they could be connectivity, but across landscapes or ecosystems. So that's what a node or a link might be represented as. And then the values of these different entities could include, for example, the capacity of different people or organizations, how they work, their economic sector, things like that, their preferences, values, beliefs, where they're located, the size or type. These are basically all kind of standard, variables that could measure something, inside or outside of a network analysis. Turning towards the links here, though, links could be measured in terms of their direction. For example, from this node to that node, or the lack thereof. If there's no directionality in these types of relationships, they simply co-occur, for example. Or the frequency of interaction or frequency of something passing between those nodes, the magnitude of the relationship, how much someone trusts somebody else or how little they trust that other person. The sign, if it's a positive relationship or a negative relationship, and so on. So these are just examples here. And there's lots of different units at which networks can be analyzed. And so I've just highlighted a few here, and these are by no means kind of discrete entities. There's a lot of fuzzy boundaries between these different units. But let's say you've got some network data and you want to do something with it, and there's a lot of options as far as the kind of the level of analysis. And I guess the point that I want to make here is that the type of analysis that you use to understand network data should really be guided by the research questions that you're most interested in. So, for example, let's say you're interested in something going on at the node level here. So for example, which types of organizations have the most influence in some sort of environmental governance network? Is it the local conservation groups or the local authorities or groups that are external to that system? You could measure that, for example, by calculating what's called a centrality measure. It could be incoming ties, for how kind of popular those people are, or organizations, or outgoing ties that would measure their kind of overall activity. So those would be examples of a node level analysis. But you might also have research questions that relate to groups of nodes. So that's what I've depicted here. These could be 2 nodes, 3 nodes, 4 nodes, small groups. That's the idea. So for example, what types of organizations broker the exchange of information about, say, for example, stewardship programs between landowners, let's say they're over here, and federal organizations? Is it these purple nodes, maybe they're agricultural extension agents, or is it some other type of organization or entity? And so that would be a question that you really need to focus on kind of small groups, in this case 3 nodes to address. And then we could turn to the whole network and regard the network as the unit of analysis. And so there you might be interested in, for example, the size of the network, the number of nodes within it, how connected it is, where the subgroups or coalitions to the extent that they exist, to what extent is the network polarized in different factions and things like that. So this is just, a highly simplified example of how you might structure different network analyses in terms of the level of analysis. All right, so why might you do network analysis? Well, one reason is that people really connect, and that's up here, with network visualizations. And this might seem trivial, but it's actually a really big deal. So people, for example, respondents in data collection, or decision makers when you're trying to communicate the results of your of analysis, they see network visualizations and they say things like, "You've captured my world. This is my reality," and that can be really important for engaging people in research during data collection, or communicating research findings to engage people kind of in terms of the implications of the research. I also felt like I should point out that network analysis is simply highly appropriate for research and study systems where relationships are really important. So by way of analogy, if you work with spatial data, you inevitably gain some expertise with GIS or with map making or some sort of tool that's really appropriate for working with spatial data. And I would say that similarly, if you're working with relational data that focuses on interactions or linkages or connectivity or things like that, you should at least have a working understanding of some of the fundamental network analysis techniques or methodologies. And to follow that point, I would say there's never been a better time to dive into network analysis because there are now tools for doing a network analysis that are free, that are increasingly powerful, and also increasingly user-friendly. So I've listed a couple of those in the resources document that's available to everyone here. And the final point that I want to make is that a network analysis seems, at least in my opinion, it's gone mainstream, at least in the fields in which we work. And so, if you're working with network data, you no longer have to really justify a network analysis, at least to, in terms of explaining your work and the value of it. But it's not all smooth sailing, and there's some important challenges that really need to be taken into account. A big one, and this is the one that I highlighted up here with this little screenshot here, is respondent fatigue. So this is a snapshot of a survey. I don't know if anybody can see, but this here just basically lists different types of organizations, and the question is, with which organizations does your organization work on, in this case, climate change, collaboration around climate change? And so all I was trying to do was to capture data about whether or not organizations collaborated with other organizations. Nothing about the frequency of interaction, the level of trust, or so on. And even so, it took a long time to collect data for this part of the survey. Another point, which is more of a statistical issue, is that network data are inherently interdependent. So ideally, you'll want network data to be as complete as possible. And for a lot of network analyses, you can't sample the network. What you really want is a census. And so that can be very exhausting. There are ways to deal with missing data, but it's still an issue. And building off of that point, to measure how much of your network is missing, you'll need to know what the boundary of the network is. And that can be very tricky, especially in environmental social science research. Who's in the network, who's not, and delineating some boundary that really makes sense. And so this final issue at the bottom here is sort of a counterpoint to what I mentioned in the previous slide about the accessibility of network visualizations. So while that's true, at the same time, networks require a lot of simplification and abstraction. And so a whole federal agency might become a dot, or the richness of social interaction between organizations or people might be reduced to essentially a 1 or a 0 or a line that represents collaboration. And I hesitate to even put this one on here, but of course, there is a learning curve for working with network data, and it could be steeper or less steep depending on what type of research questions you're trying to evaluate. So I wanted to wrap up with an example of how network analysis can be helpful for understanding environmental governance. And this was some work that, that I did with Paige Fisher and also Alan Ager with Forest Service. And so the setting here was the Eastern Cascades ecoregion in Oregon. So that was sort of helping to bound our network. Or nodes in this case were jurisdictions of organizations. So these were mapped nodes on the landscape. And what defined the linkages here was two things: a social kind of form of linkage and then an ecological one as well. And on the social side, it was organizations working with one another to coordinate wildfire risk mitigation activities. And on the ecological side, it was fire being transmitted, spreading across the landscape from one organization's jurisdiction to another. And the question was, how does exposure to wildfire shape risk mitigation governance networks or coordination among these actors? So the data came from interviews. The data came from interviews, and people were asked with which or who do you work with to collaborate or to exchange, obtain information pertinent to wildfire risk mitigation. And the ecological data actually came from simulations of wildfire on the landscape. So here you have both of them. There's the social data there and the ecological data there. And essentially, we were trying to predict or understand how this network predicted this one. And we ran what is analogous to a logistic regression model there, where the unit of analysis was interaction between organizations. So simply, we're just trying to predict dyads, linkages between pairs of organizations. And we found that under certain conditions, exposure to a wildfire predicted risk mitigation coordination, but among organizations exposed to wildfire, really large scales coordination was less likely. So there's some policy implications there. So finally, a few notes about trends. So in my view, application of network analysis for environmental social science research continues to grow. And there's also seems to be a trend towards modeling networks as opposed to describing networks. There also, along these lines, there also seems to be a trend in towards, or I should say, while kind of network level research, characterizing a whole network in terms of its connectivity or some other metric like that, used to really dominate. There seems to be a growing emphasis on research at the substructure level. And of course, there seems to be a lot more interdisciplinary applications of network analysis in the past few years. One big frontier, in my view, is understanding how network structures affect real-world outcomes. So for example, given some structural characteristic of a network, what does that say about water quality or the viability of communities that are dependent on natural resources or something along those lines? And also, another big frontier is improving the capacity of network-oriented research to inform or otherwise benefit policy and practitioner communities. So with that, I'll wrap up, and I look forward to questions. Thank you very much.
All right. Thank you, Matt. We're going to shift things over to Peter. I just need to give him control of the mouse. All right, Peter, you should be able to use, move the slides forward as you normally would.
Okay. I think there's a delay in the key or something. Yeah, okay, so I'm going to talk a little bit about quantitative content analysis. And I don't think.
You have control if you're not on the right slide, you can go back.
Yeah, I'm trying to hit the back arrow and nothing's happening.
Hey, There you go.
All right. So, yeah, okay. So content analysis can be either quantitative or qualitative. I'm going to talk about the quantitative. Here we're looking at really, for the most part, text. You can also do image analysis. You can look at different things, but primarily we're looking at different kinds of text and trying to understand the structure of text and also meaning. Unit of analysis, really just like the network analysis, you could think of the unit analysis as being like the discourses that are occurring, but I think lots of times it ends up being the discourses are made up of specific phrases and words. And this particular approach really is becoming more popular, I think, in part because it lends insight that is hard to get at otherwise. But there are definitely some connections. I was noticing that between the network analysis and this that Matt was talking about. Okay. So in doing this kind of analysis, you start off with trying to figure out what kind of text do I want to choose, and that's very purposeful. So in the slides coming up, I'm going to show you work that we published in Marine Policy and Global Environmental Politics that were analyzing what are called the SOFIA reports, the State of the World's Fisheries and Aquaculture, that are published every 2 years by the UN FAO. And we chose those because we figured that they were fairly representative of marine politics. And we had to make that case, by the way. A lot of this, you have to kind of convince reviewers of and kind of show good reasoning for that. And probably a lot of these things can be argued about. But you want essentially to choose text that you are saying is going to represent a specific voice. So for example, in 2013, my university, is like the first ESPN football game they ever had. And they put out a commercial, of course, and this would be a visual kind of thing and not even quantitative, but they had pictures of kids skateboarding, the pool at the rec center, inside the rec center, people, lounging on the grass. And at the end of the day, there wasn't a single picture of anybody studying or doing research or teaching. And I can show that to my students and say, this is representative of UCF. It went through their processes. This University of Central Florida, this was purposefully released. And so I can say that, this went through enough kind of vetting that we can be confident that that really did come from an authorized voice of my university. And it also makes them laugh. So when you're choosing the text, it's important to do a lot of upfront work. So the reports that we did, we had to kind of cut out the kind of beginning and ending sections because we didn't want to analyze that part. So for example, the citations and people's job titles, we didn't really want that to come up when I'm searching for managing fisheries. So so making sure that you're kind of cutting out text that you don't want to analyze and making sure that the text that you do want to analyze is present. That next part is meticulously creating a dictionary, because you're ultimately searching for words in quantitative content analysis. And that means that you have to make sure that you're not going to miss a discourse or a theme just because you didn't have the right word in there. Likewise, you also want to make sure that you're catching all of the kinds of words, all of the iterations of a specific term, for example, and this process is called stemming. So for example, I can tell the software that I use to search for everything. So if I'm looking for sustainability, for example, in our second paper, we had to tell the software to catch sustainable, sustained, sustaining, all those different kinds of iterations, the inflections that would be relevant for us. And then you also want to make sure that you're thoroughly filling the dictionary with the different concepts that fit what you're looking for. And so oftentimes that means using a good thesaurus, which are now oftentimes included in the software. That's very helpful. And at first glance, you can actually tell, oftentimes, depends on your software, but I tend to use one called Provalis. You can actually look at in the dictionary, in the thesaurus, and it'll show you which words are actually appearing. But that doesn't mean you don't use the words if they're not in there, because sometimes one of the most interesting things in any content analysis is what's not present. So like the lack of teaching and research in that commercial. The most important part of quantitative content analysis is the kind of validations that you want to do, because you really want to have faith that you are representing and analyzing the discourses accurately. And because we're talking about very large numbers of cases in the Sophia reports, our data were like 86,000 cases of different things that we were looking at in different through about 10 different categories. And so we have to make sure that for example, when I search for oil, because I was at first interested in kind of crude oil spills in the ocean, that I actually am sure that it's capturing the kind of oil that I'm looking for. And in fact, when you search these particular texts for oil, you get mostly fish oil. And that came up when we hand validated. That is putting our eyes on the text and making sure that the dictionary is performing like we expect it to. That is in this next slide right there. You can see where the software pulls up every case in this screenshot. It's hard to see, but every case of global warming that was in the data and how it was being used. So I'm hand validating that particular element. When you're creating the categories, which are part of this really important element of quantitative content analysis, is putting the words into categories, and you want to make sure that those categories actually work. These are intersubjective decisions, though, so you want to perform reliability tests, both with the people that are doing the coding, and then once the categories are formed, you want to make sure that those categories are coherent and that they're actually distinct from other categories. So this is an example of an internal coherence test between these keywords that I have listed there and how close they are to both to each other and then to the issue of growth, which happened to be part of our research question. And in this case, I'm showing that these sustainability words actually relate more to growth than they do to each other often in this case. But if you're creating a category, you want to make sure that they are related, and you can statistically test that. Then, as in the network analysis, there's a way of visualizing, in this case using multidimensional modeling, scaling, to visualize where the different categories are in relation to each other. Here you can see that I was working with kind of economic categories, governance, the issue of specifically want to look at overfishing, different social values that included things like equity, gender issues. And we were able to see that, yes, these categories are separate from each other. So we're not overlapping too much in the creation of these categories, and we can have fairly good confidence that we're looking at different dynamics for each category. At the kind of the first descriptive level, there's a question of how frequent is a term, and therefore its discourse. Like the network analysis, we can actually do co-occurrence analysis of co-occurrences on two different levels. One is just, for example, how proximate is one term to another. So, for example, am I looking at a term that is very, very often used in conjunction with another term, which can be important for depending on your research question. But in analyzing the SOFIA reports for sustainability, we were very interested in seeing how much growth was being used in accompanied with other sustainability concerns. And so that helped us understand that. That's the first order co-occurrence. Second order kinds of co-occurrence is actually even more interesting than that, because we're looking at the semantic distance, where milk and juice, for example, are semantically linked because they're typically near words like drink and pour. That helps us get at a lot of latent information, latent meaning that is not necessarily overt when you read it. Here's a example of what we can get from word frequencies. The descriptive analysis here shows the different bars or the different years, and here you can see that in those SOFIA reports, ironically, they were really less interested in something like food than they were over economic values, and that helps us make the case that there's a different set of norms than we might otherwise have suspected governing oceans. In this case, I'm showing you that you can test specific relationships based off of the strength and connectivity between them, and you can set in this case, it's a stress test where I can show the very, very first relationships that occur. And if I would just say, just really open it up, then everything would be related to everything else inside the data. But if I'm constricting how many relationships I'm looking at, and I just look at, in this case, the very first ones. In this case, the very first relationship is between sustainability is to economic utilitarian concerns, and utilitarian concerns are the central element of these discussions. Then there are options for you to start creating rules to search for different discourses based off of rules that you can create based off of what depending on what you want. And it's been known for a while now that you can predict what's coming in a sentence up to about 4 to 5 words distance between, so you can understand probably what's in the text using these rules in different ways. So in this case, we're looking at the way that people, planet, profit concepts are co-occurring, and the overriding element of the 3 Ps in this particular case is profit. And I was able to know that by organizing the rules to look for those things. The strengths of quantitative content analysis is that it brings the possibility of finding things that are not necessarily there, obvious, that are not obvious, because you're looking at semantic behavior and looking at the structure of that semantic behavior. So in the first paper that I'm discussing with you, we were arguing that we discovered this invisible regime that was governing the world's oceans, but that is not, that's not, they don't actually say there is this regime that's governing the world's oceans. We were able to find that based on the structure of the text, and that's our argument anyway. And you don't have any survey effects, and you don't have any, no need for IRB, so that makes it easier. It makes it easy to use with students. There's a number of software choices that are becoming more available, and the data are everywhere because you just need to find the appropriate data for your question, and you could choose from newspapers to social media. There's just a lot of choices. The weaknesses is that it's inevitable that out of those 86,000 cases I was talking about, our category was probably being analyzed incorrectly somewhere, because I can't put my eyes on every single one, especially when I'm doing kind of the connections between between categories. And while it sounds like you're just pushing buttons, it's very, very time consuming on the front end. The dictionary has to be really tailored specifically to the data. There isn't any kind of universal dictionary that's going to work for everything, and it takes a while to learn. And lastly, because this isn't something necessarily everybody gets taught when they're in grad school, it takes explicit explanation to reviewers, but it's doable. So that's it for me. Thank you very much.
Thank you, Peter. Okay, I'm gonna switch over control of the mouse to Mark Rouleau, who will be our last presenter today. And he is going to be talking about agent-based modeling.
Okay, thanks, Kathy. It looks like I have control, but it's got a bit of a delay in responding to my key touch. So far, no response.
Okay. See, what we can do then is I can take back control, and you can tell me when to advance, Mark. Okay.
Okay.
And all right. So is this the slide that you want to be on?
Sure. Yeah, we can go here. Okay. So we'll see how this goes with the two-way transition between my transition from what I'm thinking to the slide, but hopefully this works out. Anyway, so I'm Mark Rouleau. As I said before, I'm at Michigan Tech University. I'm going to discuss agent-based modeling. The goal of the presentation today is to try to answer some quick questions about agent-based modeling. First, what is it? Why would you want to use it? And how would you go about developing it, just in a basic sense? And then what are some of the limitations? So I'll start off with answering the what is agent-based modeling question first. So Kathy, if you could switch, please.
All right. Stefan, it's not advancing. Is it the right slide, Mark?
Yes, thanks.
Okay, great.
Okay, so I guess I'll start off with being overly simplistic first. In terms of describing agent-based modeling, it's all in the term itself. An agent-based model, an ABM, is a model. In that sense, it's an abstraction of reality. The goal is to emphasize certain aspects over others. In fact, it's not quite different than the presentations that you've previously been exposed to. So as with Matt's presentation in social network analysis, the goal there is to try to emphasize the nodes and the relationships between the nodes in order to basically highlight the network connections within the world itself. You can do something like that with semantic behavior as well, as Peter has shown. Ultimately, my goal is to try to develop models where the emphasis is on each particular actor of interest being an agent, modeled at the agent level. The goal is to model individual decision-making, individual behavior, and to look at that from the perspective of actors interacting with other actors and actors interacting with their environment. And in fact, Peter, it looks like we can go back even further to update your quote in terms of all models are wrong, but some models are useful. We can go all the way back to George Box in 1987 for claiming those particular facts about modeling. And I'm going to show you what it is from an ABM perspective that is so useful about the approach, what we're going to simplify, and what we're going to try to avoid oversimplifying in the process. So please, Kathy. Okay, so visual, as was already said, people like visuals. It really eases with the comprehension of the maybe technical nature of agent-based modeling. From an agent-based modeling perspective, it can be as simple as this. We have an example of here, Thomas Schelling's segregation model. I think it's a good demonstration of keeping agent-based modeling as simple as possible, keep it simple, stupid, the KISS principle, to be able to do something where the ultimate goal is, what are the simple rules of behavior at the individual level, which when aggregated together get you something at the macro level that's potentially unexpected or not directly explainable or derivable from those simple rules of behavior at the micro level. So the example that I have on, from Schelling, the left-hand side shows you what the model looks like at the very beginning. We see red dots, blue dots, and black dots. The red dots represent agents who are of a red type. Blue dots represent agents who are of a blue type, as simple as that. The black dots represent open space within this particular system where agents can move to if they feel uncomfortable about their current location with respect to their tolerance level and the percentage of others they're willing to live next to. If you develop some simple rules to do some hypothesis testing with respect to what does it take in order to get patterns like you see on the right-hand side, the model N side. What does it take to get patterns like segregated systems like we see on the right? Agent-based modeling will allow you to do that hypothesis testing in a way where you might find that what you expect at the micro level is not necessarily what's necessary to get you the outcomes at the macro level that you see on the right-hand side. Kathy, if you can move to the next slide, please.
Do you want that?
Yeah, we can skip ahead to the next.
Another one?
Yes, please.
Another slide? Okay.
Yeah. Okay. So from the agent-based modeling perspective, it again really depends on what your research motivations are, what that research question is that you're trying to pursue. I'll give you some examples of questions that would be relevant to maybe pushing you in the direction of using agent-based modeling as a methodological alternative to consider. The first question would be, does your research subject, research problem, research question have something embedded within it where space or social location matters, right? Second question would be, does actor heterogeneity matter? Does system heterogeneity matter in terms of understanding the macro level patterns that you're trying to explain? Third would be, does bounded rationality matter? Is it important for you to try to relax some of the assumptions about actors having perfect access to information and making perfect decisions, which is commonly the approach to formal modeling when you are trying to develop models based on the rational actor paradigm. Right? The next would be, does feedback across systems or subsystems matter? Are changes in one aspect of the system likely to feed forward into causing changes in the other aspect of the system, which you need to keep track of over time? Ultimately, the goal would then be trying to explain these complex emergent patterns. So if you're really trying to pursue questions that are related to emergent patterns and trying to explain how you get those patterns from the micro level to the macro level, agent-based modeling can be a very handy tool for that. And if interdisciplinarity matters, agent-based modeling also offers a number of opportunities because of its flexibility and how people can make different contributions to the model development process. Agent-based modeling can be not only a handy way of bringing many different researchers together with different research backgrounds, but also maybe in some cases a necessary requirement in order to do the ABM development well. Kathy? Probably 2 slides. Thanks. Okay. So the process of developing an agent-based model is really, I think at the outset, no different than developing any particular model. The question is, are you going to advance from the conceptual modeling stage to the computational modeling stage? If the answer is yes, then you have to have some programming background to get you to the level where you could do the ABM simulations. Right? But at the starting point, conceptual modeling, this is something that everybody can do. This is something that we all, in fact, do on a daily basis without really being conscious of it. Right? These are the thought experiments that are constantly playing out in our minds. We're saying, we see a pattern in this world. What does it take to get us this pattern in this world? We develop some assumptions about what would be necessary at the individual level in terms of individual decision-making and thought processes that go into how agents interact with other agents or actors interact with other agents in their environment to get us that pattern, right? The only difference from an ABM modeling perspective is that rather than letting those ideas remain implicit and untestable, we just try to formalize those thoughts about the world to be a little bit more explicit and to be logically consistent and to put us in a position where we can actually test out whether or not those thought experiments play out the way that we assumed that they would. So from the conceptual modeling perspective, the first step is just identify the complex emergent phenomenon you want to explain. What is that pattern that you ultimately want to be in a position to be able to say, here is how you get there. Then make explicit your implicit assumptions about how this dynamic process is supposed to unfold. Once you have a sense of what it takes at the micro level to possibly get you to the macro level, you can start identifying the relevant actors, the environment in which they interact, and their potential relationships. Then you have to move a little bit closer to the programming or formalism domain, because it's necessary for then you to work out some potential inherent contradictions between your assumptions. And so those inherent contradictions between assumptions we can get away with in thought experimentation, but it won't work when it comes to putting this into a computer program. That's when you get your errors and your program won't run. Right? So at this stage, you still want to be thinking through in terms of the logical consistency of the rules necessary to reproduce your phenomenon. And if you don't think that through well, that's fine, because later when you go to do the programming, this will show up when you get your errors. Right? And then the final step at the conceptual modeling stage would be determining the relationship between the rules and assumptions that you think are responsible for that macro level pattern you're trying to explain and the data that you have access to. And I'll just say that agent-based modeling is quite flexible with respect to exploring highly empirically grounded problems to problems that are highly theoretical. So in that sense, it's not necessary that you even have data, right? Although it's probably a bit challenging to get the process started with no data whatsoever, it is entirely possible to do theoretical experiments in the context of ABM. But if you're moving towards the direction of something like policy analysis and you really need some empirical grounding, then you need more and more data to inform the model development process. And so at this early conceptual modeling stage, the question is, what data do I have, and how can I embed that data within the model that I'm developing conceptually? Once you've done that, the next step then is to start to do some programming and turn that into a computational model. The first step in that process for those of you who have never done agent-based modeling before would simply be, what is the right programming environment for me? And programming is a challenging hurdle for most people to get over when they first start doing agent-based modeling. If you have no programming background whatsoever, I recommend NetLogo, which was a programming environment that was designed specifically for you, specifically for people who don't have really any background whatsoever in computer programming. It was designed as a language to basically convert what seems like straightforward text into something that is then computer readable. And actually what ends up happening with NetLogo is it gets translated into Java, the Java programming language, and then it's eventually compiled by the computer so the computer can execute your code. I personally have the computer science background, so I use Java myself. And then there's a number of simulation libraries that are available for those who have that programming background, like Mason, Repast, or if you're familiar with a different programming environment, other environments like AnyLogic or R are starting to develop their own packages for doing agent-based modeling. Right? So it's quite flexible. after you found the right programming environment, you need to turn your conceptual model into executable code. On the next couple of slides, I'll show you sort of roughly what that means. Once you've done the code and you have a program that is ready to run, you then need to verify that your code is working the way that you intended it to. Validation would be a key step in making sure that you have achieved structural validity with respect to what the model is doing in terms of its behavior versus what you expect in terms of the empirical reality, or lining that up with your theoretical expectations. And then once you can be quite confident that you have not only functioning code, but code that is lining up with theory and the empirical world, then you're in a position where you can do some analysis with those simulations. And so you can do anything from formal analysis to something as simple as just asking what if questions. What if we slightly altered the rules of behavior? What sort of outcomes would we expect? You can do things like scenario analysis, where you try to run multiple future scenarios, altering different features of the system slowly at a time and seeing what those effects are over time. And so there's a number of different things you can do to generate your results. Kathy, if you can go forward again. Thanks. So just the graphic depiction of the Schelling model, just so you can get a sense of what this looks like in terms of turning ideas about what causes segregation into an actual ABM. From the perspective of the Schelling model, here's the conceptual model for the agents themselves. Right? The only thing you need to keep in mind is that in the Schelling model, there's two different types of agents. There are red agents and there are blue agents. But when it comes to agent decision-making, it's the same for each, right? So we have heterogeneity, but we also have very simple rules of behavior driving the outcomes we're trying to explain, right? The very simple rules of behavior from a conceptual perspective is that once the agent is activated, and each agent can be activated in parallel or serially. Typically, this is done serially, where one agent is activated once at a time. It takes its turn, does its behavior, and then hands over the activity to the next agent. In that case, the simple rule of behavior from the Schelling model is the agent will simply ask itself, am I satisfied with my current location? If the answer is no, the agent will attempt to move. It'll move to one of the open locations in the system. If the answer is yes, the agent simply stays where it is. That's it. It's as simple as that. Right? The question is, though, what happens when agents are making these decisions without coordinating with each other in a decentralized fashion? What is the ultimate outcome of this rule-based decision-making at the macro level? It's maybe not as straightforward as you would think. Kathy, can you move to the next slide? So I think the conceptual model is very straightforward, but what I'm showing you now is how you turn that conceptual model into actual code. And not to overwhelm you too much, much of what you see here is, if it's confusing to you at all, it's simply because you're not familiar with the syntax of those programming languages. And this is Java that I'm showing to you right now. So if you've never seen Java before, it looks like there's probably a lot of garbage on your screen. But I can sift through that noise for you and help you to figure out how what was on the previous slide gets translated into code. Kathy, I'm going to need your help. Just to hit the button once, please.
Okay, next slide. Oh, right.
No,
Okay.
well, yeah, there you go. Thanks. Okay, so the first line is simply saying whatever you see encapsulated within these brackets, this is a representation of the agent itself, right? So the public class, the extend sim state, for the time being, you can simply ignore that stuff. It's all syntactic. It's something you pick up along the way as you develop your understanding of Java or whatever language you're using, right? But ultimately, what we're saying here is the agent is encapsulated in code between these brackets. Kathy, can you hit the next button, please? The next box is representing the agent's attributes. So these are the things that you use to define the agent's characteristics. Here we have a different type of agent. Agents can be red, agents can be blue. I'm saying it's a Boolean because it's true if the agent is red or false if the agent is blue. Agents have, this is in the Schelling example, agents have a tolerance threshold. In other words, they're willing to live with 50% of their neighbors being different than they are, right? So if you're a red agent, if 50% or less of your neighbors are blue, you have no reason to move. Otherwise, you're dissatisfied and you will act on your dissatisfaction by moving to another open location. Agents also have access to their neighbors. Obviously, they wouldn't be able to do this calculation otherwise. And so they're making local decisions based on what's happening in their local neighborhood, and they need to be able to be aware of at least that much of the system itself. Agents are located at a particular point in space. In this case, it's a grid with XY coordinates. So they're at a particular point within the system. Agents also need to be aware of where the open locations are, because if they do need to make a decision to move, they also need to know where moving is possible. And then, Kathy, thanks. The part that you see at the bottom, that's telling us the agent decision making. Right? This is how the agent goes about making its decisions based on its attributes in its current state. It's very simple. A simple if statement tells us that the agent is simply going to first check to see if it's satisfied. And if that method returns false because the agent is not satisfied, or sorry, if that method returns true because the agent is dissatisfied with its current location, it will then execute its move rule. If the agent is satisfied with its current location, it will skip that step and move on and return control to the next agent in the queue. Kathy, next slide, please. There's a little bit more code that goes into that. It's not quite as simple as that. Those two decision-making rules are coded out this way. Kathy, one quick, yeah, thank you. In terms of checking satisfaction, the agent will basically iterate through its neighbors. It will count each of its neighbors and say, how many of my neighbors are red? How many of my neighbors are blue? That's the first part of what you see in the code there. That's the for statement, which is just iterating from 0 to the total number of neighbors that you have, counting each one that is not like you. The if statement that follows that is simply saying, now calculate the proportion of those who are not like you within your neighborhood. If those who are not like you is higher than 50%, you're dissatisfied. If those who are not like you is lower than 50%, you're satisfied. That gets fed back to the code you saw in the previous slide to tell the code, should I execute this move function, yes or no? All right. So Kathy, one more button gets us to the move function, which is very simple. The move rule is simply, if I'm dissatisfied, I will execute this rule, which means give me a new location in this grid. Right? Make my current location a random location somewhere else in the open locations that are available to me. So there's a little bit of stochasticity that goes on here, a little bit of randomness determining how the agent actually ends up in a different location. Those are the rules that it takes, both in terms of conceptual modeling and in computational modeling, the code that's necessary to get you to these kinds of outcomes. So going from a model that starts off as a completely random pattern, no particular pattern displayed at model start, to agents then executing these rules one round at a time, where each agent is executed once during that round in a random order. If you do that over a series of steps or a certain amount of time, you eventually end up in the final, what in this case turns out to be an equilibrium state, where you see that the agents are fully segregated, nearly 100% with some little bit of stochastic noise that's still in there. Next slide, please. So before I end, I should mention something about the limitations of agent-based modeling, which probably became apparent as I was discussing how you go about developing the model. The first limitation is pretty obvious to everyone, so I wanted to not really cover that one up in the presentation. It has a steep learning curve. ABM has a very steep learning curve because you do need to have some proficiency in some programming language if you want to take that conceptual model and turn it into a computational model. It's going to require you to learn something in terms of programming. However, I will throw out there, Thomas Schelling, who actually developed the Schelling segregation model, did this with no computer whatsoever at the time. Thomas Schelling simply took a checkerboard out, or a chessboard out, laid out some dimes and pennies, and followed his simple rules of behavior one at a time with each of those dimes and pennies. Obviously, if you're doing this manually, you can see why it would take an extreme amount of time to complete any one simulation. So obviously moving this to a computational environment where you can speed up the process in orders of magnitude would be significantly advantageous for you. But it's not a requirement for doing agent-based modeling. I'll just throw that out there. Data availability can also be a problem, but of course, whose method doesn't really have this problem? But the data that you often want or need in order to develop some really interesting models may not be available to you, and you can find that frustrating, especially when you're getting started, or when you have a pretty thorough understanding of how to develop ABMs and you know what the power is in doing such a method, but you're limited in your ability to do that because the data simply does not exist. The next limitation would be trying to find a balance between model complexity and computational capacity. Now, of course, we can do things a lot faster than you could do manually on a checkerboard. But at some point, if you develop the model to be too complex, you're taxing the computational capacity more and more and more. And so there are often times where I've had to step back from being able to develop what I think are quite interesting models, but from a computational perspective are simply too difficult to handle in terms of the execution. The running time can be hours, days, or weeks, depending on the development of how complex your model is. Model complexity versus analytical clarity can also be an issue. You have to find the perfect balance between developing a model that you understand as well as developing a model that is not oversimplifying the world. And then the last one, explanation versus prediction. I'll just throw out that ultimately, most agent-based modelers get into using agent-based modeling because they would like to be in a position to be able to explain what it takes to develop these complex emergent patterns. But if you talk to people about doing ABM and they're at least aware of the fact that you're using computer simulation to do your work, they're often going to want to veer the conversation in the direction of prediction. They're often going to want to ask you things like, what does your ABM predict? What sort of outcomes can you predict with your ABM? And I'm very cautious in saying, here is what the ABM can do in terms of prediction, because I don't necessarily think that is the proper purpose of an agent-based model. At the very least, I would say, if you want to get into agent-based modeling because prediction is interesting to you, that's fine. I think you can do it from an explanation perspective, but don't fool yourself into thinking you'll be able to make point predictions. Don't fool yourself into thinking that, going back to Schelling's simple example, you'll be able to explain exactly where agents are going to be segregating themselves within a landscape. Right? If your ultimate goal is to say, I expect that I can use these simple rules of behavior to demonstrate that segregation happens, fine. You can make those kinds of predictions, right? But you can't predict where agent A is going to end up at the end of the day because the system is stochastic. There's a lot of random variability to it. It's complex, right? Even if we've simplified it as much as possible. Okay, so I'm going to end it there, but happy to follow up with questions later on. Thanks.
All right, thank you, Mark. So this is Kathy, and I'm going to stop sharing screen. And we're going to switch over to the Q&A. One more slide. And then we're not going to stop sharing. Sorry, guys. Okay, thank you. So I'm going to open up the Q&A session. We're going to spend a few minutes at a time going through the presenters one by one, starting with the first presenter. So you should click on your Q&A button, and I'm going to unmute all of the presenters, and we'll go presenter by presenter. Presenters, please don't mute yourselves again, because I'm not necessarily going to notice that you're muted again. So Stefan is unmuting Peter, and we're going to start out with questions for Aniseh. Okay, so if you have a question for Aniseh, you can type it into the Q&A box. All the attendees are muted and will remain muted. So while we're waiting to see if we have questions for Aniseh, we do have one question for Peter. So Peter, I'm gonna address that to you, and then we'll see as more questions come along. The question for you, Peter, is how do you determine the sample of documents that you want to use in your content analysis?
Okay, well, thanks, Mayra, for that question. When I'm doing the quantitative content analysis, that I try my best to not sample. So, for example, in the case that I was telling you about with the Sophia reports, I got all of them, and I try, to do that as much as I can in those cases. Sampling, I think, is more. It may depend on your data, but I think sampling is more important for qualitative content analysis, because a key step in a lot of qualitative content analysis is reducing data. So there was one study I did of archival work, and I just created a systematic rule for reducing the data. It was archival newspapers, and I was looking at oyster reports. I said, the oysters had to be mentioned 5 times, had to be on the front page, and it just did it that way. But when I'm doing the quantitative work, I really try to get the whole body, the whole corpus of that.
All right, we have another question for Peter. What software did you use, and what would you suggest for qualitative and quantitative content analysis?
So it's a good question. It may depend on your budget, but I like to use the Provalis suite of software for the quantitative work that I do, and for qualitative work, I like to use MaxQDA. We have NVivo on the machines in our university lab, but I personally like MaxQDA a little bit better. But it is different, because the software the MaxQDA is not as good at all for doing quantitative work, and so you really can't. I do distinguish between what I'm doing and what software.
All right, thank you. We have a question for Matt, and keep slowly enough that we can do it that way and keep doing it. So question for you, Matt, what software is typically used for network analysis?
Yeah, that's a good question. So if you've never done any network analysis before, a great great software for getting started is one called UCINet. It's just those letters. I'm not sure if it's commercial. There's definitely a 6-month free version of it. And so that one has a graphical user interface, so you're not writing code, and it's got a whole lot of different options for different types of analyses that you can do. There's also, if you're comfortable working in R, there's a whole set of different network analysis or network related R packages, to the point where there's almost different kind of communities of packages that kind of cluster together for doing different kind of network analysis. So I would say R packages, and particularly, so iGraph is one that's very popular. Then there's also one called the StatNet suite of packages. And so those are the 2 softwares that I'm most familiar with, and there's a whole lot of others. And so I listed a couple of those in that resources document. So there's a couple more that I'm not going to mention right now, but those 2 are both very comprehensive and a great kind of way to dip your feet into the water.
Okay, thank you, Matt. We have a couple questions from Arju for Peter. Oftentimes, folks in the development sector say that semantics will not help us understand realpolitik. What do you say to such arguments? And he's also looking for a copy of your paper on the shifting context of sustainability. And Peter, if you want to attach file that to me, I can get it to Arju later on. So the first question again, folks in the development sector say that semantics will not help us understand any realpolitik. What do you say to that, Peter?
Well, I think that what we can get at are attitudes, perceptions, norms that are found in the structure of conversations, in the structure of the things that are articulated. And it's where this becomes very useful are especially institutionalized products. For example, when we're trying to understand, say, the values of a leader, even if that person isn't coming out and saying, this is what I value, you can, it comes with an assumption, of course. The assumption is that the frequency of some iteration is in a relationship to the value that holds for the speaker or for the writer. And if you don't, if you don't buy into that assumption, then it's probably not a good approach to use. But I think it's pretty strong. There's, in the international relations literature, one of the key people who kind of looked at regimes argued that we knew that a regime was in place based on the generative grammar that was part of the environment. And I personally find that compelling, but I understand if that's a stretch for some people. Like I said, it's something I have to explain and argue usually when I'm writing these papers for journals. And I'm glad to share the article too. I don't know.
I can put you in touch with each other. I know, Arju. Thank you, Peter.
Terrific.
Peter, Arju, if you just want to send me an email and remind me that you're looking for that paper, we'll make that happen. Thank you. Okay, we have a question for Aniseh. How have you seen the methods you use translate into policy and or management recommendations? So how have you seen the methods you use translate into policy and or management recommendations?
So I can give you one example of work that we did in Rwanda, where we used choice experiments to see, there's a new policy that has been implemented in the country where farmers are not allowed to sell outside of a specific sector. And we're trying to understand if farmers were breaking that rule, and conducted some choice experiments to see when and how farmers would sell or side sell their coffee. And using those results together with other survey results, we're able to really get a good sense of the barriers that coffee producers were facing. And a direct result from that research was that on the second year of that project, the farm gate price was increased by almost 60%, which was a direct result of policy recommendations that from that project that were given to the different national boards, agricultural board and the exporting board. So that was something that we were really happy about and excited. And then in terms of one of the things that we found when I was working in Nicaragua with the risk games together with the choice experiments was that we found that farmers were very unwilling to adopt practices that were recommended because they had experienced failures in the kind of support that they were receiving from the extension officers about how to manage the leaf rust epidemic that has impacted all of the sector, the region. So that did not result in any policy recommendations that were adopted, but it really gave us a good understanding of why farmers were not adopting some of these management practices that have been promoted for so long to help them manage their farms in a way that would help them become more resilient to climate change, that would help them build better adaptive capacity to the impacts from climate change.
All right, thank you, Aniseh. We got a couple questions in the chat window, and I'll explain what they are in a moment. Those of you who have questions, if you can direct them to the Q&A window, click on that and do it. That'll make it a little easier for me to see them. But meanwhile, we'll go to the first question from the chat window about network analysis. So this is over to Matt. Would you like to use would like to use this to apply this to a systematic literature review results. Nodes could be articles or concepts, any strengths or tripping points to consider. And I'm going to repeat that, just how it's written. About network analysis, would like to apply this to a systematic literature review results. Nodes could be articles or concepts, any strengths or tripping points.
Yeah, this is a great question. Now, I'll answer it, but then I think that maybe also Peter might have some thoughts on the content part of the question. But anyway, so this is called a bibliographic network, or I think that's right, maybe bibliometric or something like that. But if I understand the question right, it would involve identifying linkages between authors, for example, or one way to do it would be to identify a linkage between an author and an article and a paper. And then perhaps to infer from that, from those types of relationships, that if the co-authors maybe know one another, or that if you're an author on one paper that involves another author who's on another paper, you can start kind of understanding how co-authorship of say papers within that body that's included in the systematic literature review might describe the whole kind of network of knowledge. So in that gets to a point that I didn't actually mention in my talk there, that there's different types of nodes. So for example, nodes could be people, or they could be documents, and you can jointly analyze those both in a network analysis. So those would be some thoughts for maybe how to start doing this like a bibliographic network from a systematic literature review. The main tripping points that I would see are trying to figure out, what do those linkages actually mean? Like, can you really assume that co-authors on a paper, for example, know one another, or they exchange knowledge? Hopefully that's the case, but if you're talking about very long lists of people that contributed to a publication, maybe not so much. And then the other one is, the papers might be published over many years. And so you can only cite a paper that was published before, for example, your paper. So accounting for that kind of temporal dimension to the data, I think, would be also very important. So that's all I'll say on that question there.
All right, thanks, Matt. So we have another question for Aniseh from Chaco. For each individual engaging in the risk preference games, how many times did they engage in the game? And also, did you find that people easily understood the game? So one more time, for each individual engaging in the risk preference games, how many times did they engage in the game? And did you find that people easily understood the game?
So each individual played the game once. So it was only one time engaging with a game, one time engaging with a risk game with a 50-50 probability, and one time playing the game with ambiguity about the probability. And for the most part, they did understand the game. What the biggest challenge was actually helping them understand the concept of probabilities and what it meant that there was a 50-50% chance, or there was an uncertainty about the probability of an outcome occurring, and that we just actually took out the balls from the bag and showed them to them and explained a little bit about the probability. So that was the biggest challenge, explaining probability, but not the concept of a bad harvest, and that getting an orange ball means one thing and a white ball means something else.
Okay, one more question for you, Aniseh, from another person. Can you please provide the names of manuscripts or report outputs from the studies you shared? I would like to take a look at them. So Aniseh, if you want to
Absolutely.
pass it to me, I'll get that uploaded to the resource section.
Yeah.
Okay. All right. That's it for questions so far. I'm going to pause for just a moment and see if any more come in, and remind you, I've got a couple things to say at the end, but one thing I want to remind you of is to please do the poll that we have open before you leave the Zoom. Okay, looks like that's it for questions. So I want to thank very much all of our presenters today and all the people who helped to put this together. I'll note that we have another Methods seminar, Methods 2, planned for late 2019. That one we're planning to have focused on qualitative participatory methods. I want to thank all the attendees who joined and ask you to please renew or join one or more of the following organizations: AESS, IASNR, SCB, SSWG, to ensure we can keep doing more webinars like this. We need you to be members. And for those of you who are members already, thank you very much for your membership. Please follow us. ACE, IASNR, SCB, SSWG are all on social media, Facebook, Twitter. So please come and follow us. And I know that IASNR and SCB, SSWG, we're happy to promote your new publications or projects. So you can just drop us a tweet or get in touch with us and we'll promote that for you. The recording of this webinar is going to be available soon. So watch the ACE, IASNR, SCB, SSWG websites, listservs, social media for announcements of where to find that. Again, thank you to our 4 presenters, Aniseh, Matt, Peter, Mark. Thank you again to all of you who attended. And please complete the poll and have a good afternoon for those of you who are in the Northern Hemisphere. Thank you, everybody.
Thanks for organizing this, Kathy.
Yeah.
Thanks.